the same.
At one point?
I'm sorry.
At one point? At one point?
No, they don't meet at one point. They don't. Yeah.
They stay the same distance from each other?
They do, but I need a definition here. Two lines that never meet. I'm sorry, what? Same point? No.
I said.
What about what makes these guys parallel? They never meet, but they're also what?
Beside each other.
Yeah, beside each other. It's kind of...
We give up.
We give up? Who said that? Who said that? Two lines that do not meet in the same plane. Okay. They're in the same plane. They're on the same piece of paper, all right? They're on the same blackboard. They're in the same plane, all right? Here are two lines on the same plane that never intersect. Never touch. Hey, those two lines never touch. They're not in the same plane. They're two distinct planes. So this is our definition of parallel lines. I just tell you that definition, ladies and gentlemen, to let you know that mathematics is precise. And definitions are precise. You leave out a little thing, you need to refine it. All right, let's just say, for argument's sake, that the slope of that line is 2. Anybody want to make a conclusion?
The slope of the other line is 2.
Got it. The slope of the other line is 2. You're absolutely correct. Your intuition says, hey, parallel lines, I think this one's got the same slope as that one, and you'd be absolutely correct. And the statement we're going to make to reflect that observation is this. If two lines are parallel, they what? Have the same slope. If two lines are parallel, they have the same slope. That's called a conditional statement. It's got an if and a then. Okay? If it is the weekend, I'm not going to be going to school. If, then statement. If, then statements have something called a converse, in which the if statement and the then statement are switched. Now, it doesn't have to be true. For instance, if it's the weekend, I'm not going to school. Okay, let's do the converse of that. If I'm not going to school, it's the weekend. Is that necessarily true? No. I could be sick, I could be playing hooky, I could be not in semester, something like that. So just because you can make a converse doesn't mean it's going to be true. Let's think about the converse of this and see if it's true. First of all, what would the converse be? If two lines have the same slope, then they're parallel. What do you think?
If two lines are parallel, they have the same slope.
So if two lines are parallel, they have the same slope. How about if two lines have the same slope? Are they parallel?
No.
Can you think of an instance in which they're not? They're symmetrical. Let's talk about it in terms of a plane. All right, very good observation. Let's talk about it in terms of a plane. On the blackboard, if two lines have the same slope, are they parallel? Oh, go for it. You say no.
In terms of what's on
And in terms of these guys, if these two guys had the same slope, do you think they're going to be parallel? They are. They in fact are. If I got two lines that have the same slope, they're going to be parallel. In fact, I can actually use that to prove that something is a parallelogram. Remember in geometry, you had things like, prove this is a parallelogram. You had different standards by which you could look at a quadrilateral and prove it's a parallelogram. Well, Here's a way I could prove this thing's a parallelogram. Show that that slope and that slope are the same, and show that that slope and that slope are the same. That means opposite sides are parallel. By the definition of a parallelogram, they're parallel. All right? So the converse of that is true as well. Two lines are parallel, got the same slope. Two lines have the same slope. They're going to be parallel. And that's important because of our next scenario. In this next scenario, I'm going to give you a line that is parallel to your line and a point that your line goes through. Okay, so your line is parallel to that line, and it goes through the point 1, 7. Hey, what you think you're going to glean from the information? What are you going to get from the information that your line is parallel to y equal 3x minus 19? The slope. Yeah, that's all you care about. If your line is parallel to that line, your line has the same slope as that line. So what I want to get from that line, the only thing I want to get from it is its slope. So the slope of this guy is what?
3.
Hey, there it is right there. That's the slope. Now, I don't even have to tell you this or ask you this, but if the slope of that line is 3, what's the slope of your line?
3.
Yeah, okay. So now look where we are. It's got a slope and a point. That's scenario number 2. Right back to scenario number 2. I've got an x and a y and an m. So let's substitute. For that, a point is an x and a y. So let's see, y is 7. Slope is 3. X is 1. I don't know b yet, but I have a feeling it's going to be pretty easy. Yeah, subtract 3, b is 4. Now look where we are. Scenario number 1. Got the slope, got the y-intercept, fill it in, I'm finished. Y equals 3x plus 4. Okay? So if I give you a line that is parallel to your line, you want its slope, because its slope is your slope. All right, let's do a subtle one here, not quite so direct. Your line is parallel to the x-axis. And it goes through the point 2, 9. Who wants to make an observation? Yes, ma'am.
That the slope will be undefined?
Okay, if it's parallel to the x, here's the x-axis. If it's parallel to the x-axis, what kind of line is it? Parallel to the x.
Horizontal.
Horizontal. And look at your notes. If you need to, what
It's going to
kind
be
of
0, huh?
0? Very good. Y'all see that?
Yeah.
See the thinking? It's parallel to the x-axis. One of these lines. So it's a horizontal line. Look at your notes if you need to. That's what you got your 3x5 card for. Horizontal line's got a slope of 0. Got my slope. You can think about it like this. If it's a horizontal line, it has the equation y equals something. What do you think it's going to equal? Y equals 9. There There it is. There's the y. So you can think in terms of several different directions. Get the slope, fill it in for y equal mx plus b, solve for b, it'll turn out to be 9. Or you could simply say, hey, your line is parallel to the x-axis. That means it's a horizontal line. But wait a minute. A horizontal line has the equation y equal something. And here's the something. There's the equation of my line right there. And I knew that. I knew that if I just had y's in my equation, it's going to be a horizontal line. And likewise, if I have a horizontal line, it's just going to have y's in there. And the point tells me what the y value is. Is that okay? Parallel to a particular line, get its slope. That's what you need to get from the line that is parallel to your line. All right. Let's make another observation. This is one of those questions that unless you have some background or some experience in this area, you're probably not going to get it right. Let's say these two lines are perpendicular, meaning they intersect to form a
Right triangle.
right angle, 90-degree angle. Okay, and let's say, for argument's sake, that the slope of this guy is 2. It could be. It's going lower left to upper right, so I know it's positive 2. Hey, in general, tell me about the line that's perpendicular to it. Negative, right? Can you tell that already? It's going upper left to lower right. If this guy's going lower left to upper right, the one that's perpendicular to it will be going upper left to lower right. It's going to have a negative slope. So that much I know for sure. It's negative something. Anybody want to guess negative what?
2.
Yes, ma'am.
The reciprocal of 2.
The reciprocal is absolutely right. Now see, that's why I say it's not obvious. Because I would have guessed, I'm thinking negative 2. But I'd have been wrong. You're right. It's the negative reciprocal. And if I think of 2 as a fraction, and turn it upside down, negative 1/2 is the slope of the line perpendicular to it. So here's the observation we have just made. Lines that are perpendicular have slopes that are negative reciprocals. In other words, you change the sign and turn it upside down. Lines that are perpendicular have slopes that are negative reciprocals. And what that means is, if I give you a slope, you can give me the slope of the line that's perpendicular to that one, right? Let's see. Let's assume these two lines are perpendicular. And I got one slope and I'm looking for the other. I got the idea? These two lines are perpendicular. If the first slope is 2/3, what's the slope of the line perpendicular to that? Very good. You did two things, right? You turn it upside down, you change the sign. So it's negative over 2. If the slope of the first is -5, what's the slope of the second? 1/5. Positive 1/5. You change the sign, you turn it upside down. Okay, you want a sneaky one? How about this one? If the slope of the line is 0.9, don't come out 1/0.9. Very good. How did you think of 0.9 then?
9/10.
Isn't that another way to say 0.9? Don't you even say that? If I said, how much is this? You say it's 9/10. That is a way I can think of 0.9. So that gives me the advantage of taking the reciprocal, make sure I